The frustration of modern air travel is something nearly every passenger can relate to. Delayed flights, expensive fares, last-minute cancellations, and the hassle of traveling long distances just to reach a major airport have become all too common. But now, Tesla has stepped in to transform this experience entirely. The 2026 Tesla Super Electric Plane isn't just another aircraft, it's a complete rethinking of how aviation can work, built to eliminate the inefficiencies and frustrations that travelers face daily. Imagine a future where flight schedules run on time, not by chance, but by design. A future where ticket prices drop without sacrificing reliability, and where flying from a smaller local airport becomes a real option again. That's exactly the world Tesla is aiming to create. The 2026 Super Electric Plane represents Elon Musk's vision to make air travel faster, more affordable, and more sustainable by using the same electric innovation that revolutionized the car industry. The most groundbreaking part of this plane lies in how it operates and how it's maintained. Traditional aircraft rely on complex turbine engines that require constant inspection, lubrication, and intricate mechanical upkeep. Even small issues can ground a plane for days. The Tesla Super Electric Plane, however, replaces this outdated system with modular electric propulsion pods, a design that allows for fast, simple maintenance that cuts downtime dramatically. Each propulsion pod is a self-contained system, including an electric motor, inverter, and propeller. They're designed to connect through standardized fittings that handle structure, power, data, and cooling all at once. When one of these pods detects a malfunction or fault, it can be swapped out within just a few hours. A small team of 4 technicians can remove and replace a faulty pod with a pre-tested spare in about 4 to 8 hours, followed by only 30 to 60 minutes for propeller balancing and ground testing. To put that in perspective, repairing or inspecting a traditional turboprop engine typically takes anywhere from 3 to 10 days. This is a massive difference, days of downtime replaced by just a few hours of quick, efficient maintenance. That means fewer grounded planes, fewer cancellations, and a far more reliable flight schedule overall. Instead of disassembling engines and performing deep internal repairs, Tesla's approach relies on simple replacement of full modules, saving airlines enormous amounts of time, labor, and cost. Older turboprop aircraft require an astonishing 4 to 6 hours of maintenance for every hour of flight, a massive burden on operators. With the Tesla Super Electric Plane, that figure drops to around 1 to 2 hours per flight hour, representing a 50 to 75% reduction in maintenance workload. This efficiency doesn't just improve reliability, it revolutionizes airline economics, because each propulsion pod is modular. Airlines can keep pre-balanced spare units in storage, ready to go. That means when something goes wrong, there's no waiting for parts or lengthy troubleshooting. The defective pod comes off, the replacement goes on, and the plane is ready to fly again the same day. This system can reduce aircraft on ground AOG, time, essentially the period when a plane is out of service due to mechanical issues, by 30 to 50%. The direct impact on performance is impressive. On-time flight rates could jump from an industry average of 78% to as high as 86 to 88%. The practical outcome for passengers is huge. Fewer cancellations, less time stuck in terminals, fewer rebookings, and less chance of overnight delays. For airlines, this means better utilization of their fleets, more daily flights, and lower costs per route. Even more importantly, the simplified maintenance and reduced technical staffing needs make it feasible to operate from smaller local airports again. Traditional aircraft require large maintenance facilities and teams to keep them running, which limits operations to major hubs. But Tesla's electric aircraft, with its smaller maintenance demands, can easily be serviced and turned around from regional airports, reopening routes that were long abandoned. Due to high operating costs, these operational improvements naturally lead to major financial benefits. For most short regional routes, power plant maintenance represents about 20 to 30% of total operating costs. With Tesla's streamlined system, airlines can slash those expenses dramatically. Lower labor hours, less hangar time, and fewer parts to replace translate directly to a 15 to 25% reduction in cost per seat kilometer, key metric for airline profitability. To see what this means in real terms, consider a short 300-kilometer flight on a small regional route with 19 seats. Traditionally, at around 20 cents per seat kilometer, that trip would cost about $1,140 in total operating expenses. Tesla's design could cut that by roughly $200 to $250 per flight, giving airlines more flexibility to reduce ticket prices while still improving profit margins. This balance between affordability and dependability could make short-haul flights not only cheaper, but also more consistent and sustainable. The modular system also introduces an important safety element. Every time a propulsion pod is swapped, it undergoes a strict verification process to ensure flawless operation. Technicians perform high voltage, insulation resistance checks, pressure test the cooling system, and dynamically balance the propeller to confirm perfect alignment. This ensures that despite the fast turnaround, safety isn't compromised. Each component is monitored digitally. With Tesla's AI-based maintenance software tracking wear, performance, and diagnostics in real time, the concept might sound futuristic, but it's rooted in the same philosophy that has guided Tesla's automotive design for years: simplicity through smart engineering. Just as Tesla cars have fewer moving parts than traditional vehicles, the super electric plane removes unnecessary complexity from aviation. No combustor, no oil system, and no bulky gearbox means fewer things can break, and everything is easier to maintain or replace. This radical simplification doesn't just cut costs, it transforms the way we think about aviation logistics. Smaller airports, once sidelined by high maintenance demands, can now become central to the flight network again. With fewer crew requirements and quicker turnaround times, local routes can reopen, making regional air travel both practical and affordable for more people. Instead of enduring long drives to major hubs, passengers could simply board at their nearest airfield, making travel far more accessible and efficient. Tesla's approach also promises a quieter, cleaner, and more environmentally responsible form of flying. With electric propulsion replacing noisy turbines, the aircraft produces less sound and zero emissions during operation. This opens the door for routes that were previously restricted due to noise or pollution limits, especially in urban or suburban areas. The Tesla Super electric plane could make it possible to fly from smaller airstrips located much closer to cities without disturbing surrounding neighborhoods. Elon Musk's broader vision goes beyond the aircraft itself. By connecting these planes to renewable energy sources and Tesla's battery storage systems, entire air networks could eventually operate with net zero emissions. Maintenance facilities could be powered by solar arrays, and battery packs could be charged directly through Tesla's grid systems, ensuring a fully sustainable flight ecosystem. From a passenger's point of view, this all translates into a better experience: less waiting, fewer disruptions, and simpler boarding processes. Imagine arriving at a small regional airport just 15 minutes before your flight, skipping massive terminals, and taking off without long lines or last-minute cancellations. The promise of the Tesla super electric plane is to make air travel as simple and dependable as taking a train, except faster, quieter, and cleaner. The combination of lower maintenance costs, higher reliability, and distributed flight networks could completely reshape short and mid-range aviation. Routes between small cities could thrive again, business travel could become easier, and tourism could expand into regions previously unreachable by major airlines. By cutting the cost per seat and improving reliability, Tesla's design could enable airlines to operate profitably even on routes that were once unfeasible. In essence, this isn't just a new plane, it's a new infrastructure model for aviation. Just as Tesla's supercharger network revolutionized the electric car industry by enabling convenient long-distance travel, a network of electric-friendly airports and maintenance hubs could redefine air mobility. The same AI that monitors Tesla cars and optimizes routes could soon manage flight scheduling, pod health, and predictive maintenance for electric fleets, creating a seamless travel experience. And perhaps the most remarkable thing about all this is how natural it feels in the Tesla ecosystem. The company has always focused on vertical integration, designing its own batteries, motors, software, and even energy systems. That same philosophy now applies to aviation. From the propulsion pods to the power management systems, every component is designed to work together, minimizing failure points and maximizing uptime. The 2026 Tesla super electric plane could mark the beginning of a new era where flying becomes as efficient, predictable, and eco-friendly as driving an electric car. Reduced maintenance time, fewer delays, and lower costs per flight aren't just incremental improvements, they're foundational shifts. By replacing complexity with modular simplicity, Tesla is changing not just how we build planes, but how we experience air travel itself. It's a future where flights don't feel like a gamble. A future where you,